Hello everyone, let us get started with C++ certification training. So we are going to look at what are virtual functions. The topics that we are going to cover are what is a virtual function, what is binding, and finally what is abstract classes. So let us begin our discussion with what is a virtual function. So virtual function is a function which is defined in base class and then redefined with same signature in the subclass. It uses keyword virtual in the base or a superclass. So let's say I have a class here which is a base class, and I have one more class here which is a derived class, and D is inheriting the base class B, right? Now virtual function is function that is called depending upon the object where the pointer is pointing to rather than the type or reference to the pointer. Now this we will see with an example that if you have a pointer and if this pointer is pointing to whether object of D or whether object of B, that will determine whether the virtual function or rather the function will get called from B or class T. We will see that with an example in some time. Now virtual functions are used to implement runtime polymorphism, where the call to the method is deferred till the program is running or executing. So because of this concept that a pointer is pointing to which object, whether it is an object of B or object of D, that is determined at runtime, and therefore which method will get called is also determined at runtime, and therefore it is known as runtime polymorphism. Now a function is declared virtual by using the keyword virtual in the superclass. So if you have a function fn, let's say we have to add a keyword virtual with this function, which we will see with an example in some time. Now when a function is declared as virtual in a class, all the subclasses that override this function have the function implementation as virtual by default. So this is a concept that you have to know of. So let's move on to the next slide. Now, what is the need for virtual function? So let us consider the following example to understand the need for virtual function. Now, without the use of virtual function, we will get early binding, which implementation gets called is decided at compile time. So basically what is early binding? So let's say if you again had a base class, right? And let's say you have a derived class here, right? Now this time I'm going to take as car, and this time I'm going to take BMW, right? And BMW is extending class car. Now whether a method from car is called or BMW is called, that determination can either be done at compile time or runtime, right? So let's say you go and buy a BMW, you would expect the method of BMW getting called instead if somebody buys a car or an ordinary car, right? Now when you are compiling the program, so before you run this particular piece of code, you have to compile it, and during compilation, if the compiler knows that okay, you have to call the method from car or from BMW, then it is known as early binding, which is determined at compile time. Whereas if you make use of virtual function, we get late binding, which implementation will get called is deferred till runtime. So whether you are going to call method from this or this will be determined at runtime. This concept is known as late binding, and this is a concept which is used for virtual functions. So let's move on to the next slide then. Now, what are some of the rules of virtual functions? They are always defined in base class and overridden in the derived class, but it is not mandatory to override in the derived class. So this is one of the rule of creating a virtual function, wherein you have to override it in the derived class, but it is not mandatory. Now the virtual function must be declared in the public section of the class, and then they cannot be static or friend functions. So static or friend functions cannot be virtual functions. So if you have to make a function as virtual, they should neither be static or a friend function. Then virtual function should be accessed using a pointer to achieve runtime polymorphism. So you cannot simply create a reference, and by reference you cannot just call them. And we will see with an example shortly that if you have to access them, you have to make use of pointers to achieve or implement the function of, or rather implement the concept of virtual functions. Now, before we actually look at the coding implementation, let's try to understand what is binding. So binding for function means that whenever there is a function call or wherever there is a function call, the compiler needs to know which function should it be matched to. So let's say if you have a class A, right, and it has a method m1, right? So if you say a and then a dot m1, you can call method like this, right? Now this is called binding, meaning that the compiler knows that for this particular object, this method is supposed to get called, right? So the compiler needs to know which function definition should it be matched to. Now this depends upon the signature of each function declaration and assignment that are taken. So whatever is the signature of this method and the type of arguments that you are going to pass to this particular method, all that is going to determine which function is going to get called or which particular method is being bound to this particular call, right? Also, the compiler needs to know when this matching between the function call and the choosing the correct definition will happen. So when meaning whether it has to call M1 from superclass or M1 from subclass, it has to know whether it has to be done at compile time or runtime, right? So this is a concept of binding in C++ programming. So now let us try to understand with a small piece of code. uh, let's have a look at a small piece of code here and understand this. So first of all, what is early binding? Now, when the compiler is able to define the call to method at compile time, it is known as early binding or compile time polymorphism. Okay. Now, although here you will see that I have an animal class from here to here, right? And there is a dog class which extends this particular animal, right? Now it has animal sound and it has also animal sound method. Now here I create a pointer, right? And that points to an object of dog. And if I try to call animal sound, it is going to call me, or rather it is going to call. So the output, as you can see, although you have the parent class pointer pointing to instance of the child class, it invokes the parent class version of the function. So this is basically going to call this particular method here, right? So we will get an output as this is a generic function, for example, right? So this is early binding, and early binding meaning that during the compilation of the code, the compiler is aware whether it is going to call this method or this method. But in this case, it will call the method at one, and this is determined at compile time itself. So this is known as early binding. Now let us try to understand then late binding. So late binding is in case of late binding, whether the method from super or base class will be called or method from sub or derived class will be called is determined at runtime or when the program is running, right? Now, same example, animal, dog extending animal. Now here, if you will see, I have made use of a keyword virtual here, right? And the reference of object pointer of the type animal, but it is pointing to dog. So basically my reference is of type animal, but it is pointing to an object of dog, right? And when I say object with this notation animal sound, this time it is going to call this output, or woof will be displayed, which is the output from the subclass object. So basically, as I had explained earlier, that when you make use of a virtual function, as you can see here, the output which is displayed will be from the method where this pointer is pointing to. So this pointer, so if you think of this as a heap memory, right? This is a object of dog and your obj is pointing to the object of dog, which is a subclass here, right? And therefore this object will call the method from this subclass, which is this particular method. And this determination is done at runtime, or when the program is executing, that time it will come to know whether it is calling this method or this method. Whereas in the case of early binding, it was determined at compile time itself. So this is a concept of runtime polymorphism in C++. Now let us understand the concept of what is an abstract class. Abstract class is defined as a class with one or more virtual functions. Now, an abstract class are essential for providing an abstraction to the code to make it reusable and extendable, right? So let's understand this with an example. Suppose you have a shape class. Consider an example of shape class, which is a base class with subclasses triangle and rectangle. I have two subclasses that inherit the shape. Now the function will be declared in shape class. However, it cannot be defined there as a formula for the area is different for each type. So let's say I have a formula to find out shape or maybe find out area or find out perimeter or whatever it is. It will be different for maybe rectangle and for triangle also, right? So I don't want to give the implementation in the superclass, but I want to give it only in the subclass. But because it is a shape, it becomes mandatory for me to define a virtual function here for which I'm going to provide definition in the subclasses. So this is a concept of abstract class. So a virtual function which is marked as having no implementation is known as pure virtual functions. So basically what we are trying to do is we are trying to create a function which is virtual in nature and which does not have any implementation. It is known as a virtual function. So let us see a coding example or a sample code for this particular concept. So if you will see here, what I have done is I have a shape class starting from here, ending here, and public access modifier. I have defined this function as virtual. Now it ends here. As you can see, this particular function does not have any body. This is known as pure virtual function, right? And then you have the normal method to set width, set height, and the protected members maybe. Now you have a rectangle which is extending the shape, right? Or inheriting the shape class. Now here, this particular method has been defined here, as you can see, right? It has been given body with open and curly braces. Here you can give, in case of rectangle, areas width into height, right? And in the case of triangle, you have a different formula. So as you can see that in case of abstract classes, you have a virtual function which has no body, and we give the definition of that in the subclasses. So function is declared to set width and height. These are normal functions. The implementation of area is specific to the rectangle and triangle, and the output for this will be as per. So now what I'm doing is I'm creating object of rectangle, triangle. I'm setting width, setting height, setting width, setting height, and now if I call this for rectangle, it will get called. This particular method or area method will get called, and it will display me the area for this particular rectangle, and similarly for triangle. So basically, in essence, what we have done is we have defined a abstract class. What is an abstract class? It is a class which does not, or rather I should say abstract class is a class which has a abstract method. And what is an abstract method? It is a method which has no body at all, and the definition of that body is given in the subclasses, which is inheriting that superclass. In this case, the superclass is a shape class. So to summarize our discussion, at the end of this session, you should be able to understand what are virtual functions, understand the difference between early binding and late binding, and then understand and implement abstract classes in C++. So to summarize all this, we have looked at what are virtual functions, what are abstract classes, right? And so to summarize our discussion, we have seen what is a virtual function. We have seen what is binding, early binding and late binding, and we have also seen what is abstract class in C++. That's all in this discussion. Thank you so much for your time.